Hello, welcome to today's webinar. We're going to go ahead and get started. I know we have a lot more people filtering in. It's 10:01 a.m. in Central Time. Your time is very valuable. We're going to get you in and out, get this material delivered. It's an exciting topic, and well, I'm blown away by the interest and just the sheer number of people we have on this webinar. It's awesome. I see we have lots of leaders, senior developers, architects, development managers. Lots of very senior leaders in development organizations, and I'm honored that you would spend a little bit of time this morning talking about DevOps architecture for an Octopus Deploy based pipeline. And and a lot of you are probably already using Octopus Deploy, but you know that that tool is the first and most mature product for automating deployments. And it makes it easy to orchestrate releases and deploy .NET applications on-premise and in Azure. And whether you are a current user of Octopus Deploy or merely looking forward to a DevOps implementation to get that automation, you need a streamlined architecture, a streamlined DevOps architecture for promotion across pre-production environments and production environments. And you also need to limit who can deploy to production, ensure the releases have been tested before they go live, and then block promotion of broken releases, and have a smooth flow there while keeping back problems. So many teams are asking common questions about how to structure deployable application components and how the deployable components fit in with other elements in the DevOps pipeline and how to orchestrate it. And this is where we're going to talk about that, how it fits in. The documentation of Octopus Deploy is really great, and I'm not going to repeat all the documentation and just how to use a particular feature of that. I'm talking about architecture today. We're talking about the concepts and how to structure your DevOps environment when using Octopus Deploy, and how to interface with the parts that happen before Octopus Deploy gets control and after Octopus Deploy has done a particular deployment and environment configuration. And so overall, logistics-wise, there's a QA window in the Zoom software. You can put in a question at any time, and I'll try to get that answered for you in line. I'm pretty good at working in questions during the presentation. However, I will make the commitment that if there's any unanswered questions, I won't end the webinar until those have been answered. All right, the agenda is in front of us, and we're going to go through the objective of DevOps. We're going to talk about DevOps and architecture, and we're going to go through the 7 key parts of a DevOps architecture. And we are going to dive into some Octopus Deploy specific features that aren't really, they're buried in the documentation. They are there, but they're of architectural significance because of how some of the ways you need to structure the pipeline. And then we'll talk about next steps, how you can really get started on what we're talking about today. So let's go to the next slide. We do have a free offer for everybody who is on this particular webinar, and that is a free offer of my latest book, .NET DevOps for Azure. You can either email me directly, but on the webinar you can also put it in the chat window or put in a question in the Q&A window. And Rain, who's assisting me with the webinar, she'll make sure that you get a free digital copy of the book. And the book kind of is a broad overview of just .NET DevOps in general. It does have an Azure slant. Also, a previous webinar was really interesting that I did with Paul Stovall, the founder and CEO of Octopus Deploy. And we are the most active United States United States implementation partner for Octopus Deploy. And so if you're in the US and you already have a significant Octopus Deploy and you've used a consulting partner, chances are it was our practice. But you can go to bit.ly/octopus database, and you can watch a recording of that webinar. And we actually dove into specifically database DevOps and how to automate the deployment and the configuration and creation of the database, because it has some specific concerns. All right. Another resource that you'll probably be interested in is my podcast, the Azure DevOps podcast. You can go to www.azuredevops.show to see that, or just look it up in any of the podcast directories. So now let's talk about our objective for today. There's 3 things that we need to get right when we are putting together a high functioning software team. And if your title is architect or manager or anything where you are the leader of an organization, where you're responsible for getting output from that organization, you need to think about these 3 things. One is the software architecture, the other is budget and schedule targets, and the other is the actual organization itself. So with the right strategy, things just fall into place. With the wrong strategy, no level of execution can make it great. And architecture is a special type of strategy. And we have these 3 types right here on the screen. But DevOps, it helps give us a model to ensure that we identify all of the needed architectural elements in our strategy. And the 3 ways of DevOps are flow, feedback, and learning. All right, so let's just talk about DevOps and architecture for a minute. There's a few inputs and some outputs. It can be easy to think of architecture as the structure of an application, and it is, but the DevOps environment is a system. So you want to design the full system, not just the .NET application, okay? The DevOps environment is your organization's software system, your organization's software factory. It is the capability to produce valuable software from ideas. So the input of that system is a feature request, a change request, or usage data about how your customers are currently using the software, and you get an idea for how to change it. The output of this system is a new feature that you can use, it's a change that's in use, or it's better telemetry. It's better observability of the system so that you can know how successful it's being, all right? I can get to the next slide here. All right, so we have a model for DevOps-centered software engineering that gives you the things to think about in your strategy. And the process for DevOps is the ability for the organization to spin around the outside of this model: plan, code, integrate, package, release, operate, learn. You want to go through that cycle as fast as you can, faster and faster and faster. But in order to do that, you have kind of a multi-layered approach for this capability. And for each of those layers, you need your strategy for that layer. You need to execute it with discipline. You need to have measurement. And so the overall DevOps architecture is all of these capabilities. In the middle, you have your automated DevOps pipeline, and we intentionally kind of downplay it, but it's the ability to promote code and get feedback. But you also need to think about what practices you're using, how you're going to remove defects, what the team workflow is going to be, what the blueprints are for what you're building, and then your cloud operations, how you're going to operate that system. And so those are important. But let's dive into the center black dot, the automated DevOps pipeline, which is really the focus of today's webinar. And this is a highly shrunken technical blueprint for the structure and flow of a pipeline implemented with Azure DevOps Services and Octopus Deploy. And it has a continuous integration build and a 3-tier deployment pipeline. I want each of you to have this. So Rain is going to be posting a download link in the chat. So make sure to grab that. And if you have any colleagues who need the link, just reach out. We're happy to get it to you. And this is a high resolution PDF. You can print it on a plotter, 2 foot by 3 foot architecture D paper. In addition, you could take it to your local print shop and get a big one blown up for your wall. But this is just the top third of the architectural poster. And you can, aside from printing it out, you can dive into every aspect of it, and it'll cover all of the key things that need to be in that critical part of the pipeline. So this is the architecture for an automated DevOps pipeline, shows where the 7 key steps fit in. And we're going to go through each of them, and I'm going to talk about how each has to be done right in order to have success with an Octopus Deploy implementation. Now you can see how we put Octopus Deploy when we're deploying. However, there are things that need to be done in a specific way way at the beginning of the pipeline if the implementation for Octopus is going to succeed. And there's things that have done improperly in, for example, source control structure, then you can put a lot of effort into your Octopus Deploy implementation and it still won't come out well. It still won't work the way it was designed to. Octopus Deploy is designed to work a particular way, and there's some things that you need to think about in the structure of your source control, some things you need to think about in the structure of your continuous integration build and your package management that make Octopus Deploy's feature set just fall into place. And we're going to go over what those are. Because if you miss them, then your team's just going to be struggling to get it going and capture the full benefit. Okay. So that's the top structure. This is the full poster. I know you can't read any of the text there, but that's the full poster when you download it in high resolution form. All right. So the 7 key elements of a DevOps environment. Right here on the screen, your pre-code design process. Yep, there are some things that we need to think about even before we've written a line of code. Then our version control system structure, how we do the build, how we do full system testing, how we do user experience testing, production release, and then telemetry observation, how we know how it's going. All right, so let's dive into before we write any code. And that is the pre-code design process. Now, this is the overall process for any effective DevOps environment, okay? You can see at the bottom we have 3 types of environments. And you know, you're never going to have fewer than 3 because there's 3 unique types of environments and you need 1 of each. And we'll go into that. So before code happens, there are 4 types of designs that have to be done so that the right code gets developed. And that's conceptual design, user experience design, technical design, and acceptance criteria or test design. And you can do those really, really quickly for a particular feature. But if you omit one, then the developers are not going to have the right patterns, not going to have the right implementation details in order to get it done. And they'll make tons of assumptions and be trying to catch up. So conceptual definition is, what's the business objective? What are we trying to build? What are we trying to accomplish? User experience design is, what progression of screens is the user going to see? What is the experience the user is going to have in order to allow them to do something to fulfill the concept? Then technical design, what libraries are we going to use? What NuGet packages? What patterns? What architectural elements need to be added to the software application itself? Those kinds of things. Then acceptance criteria or test design. By the way, if you're using Scrum and you like using acceptance criteria, a test scenario is the best implementation of Scrum's acceptance criteria. And that is based on the concept, the user experience design, the technical design. How would we put together a full system test? If someone was going to manually check out that this feature is done correctly, what is the sequence of steps that they would do? And it could just be bullet list. It literally can be just go to this screen, type in this, hit a button, assert this or validate this. And it's just a simple bullet list. Armed with that, the developers know exactly what to build, exactly how to build it, and they can script out the full system tests that are the acceptance criteria while they're writing the code. And they can use frameworks like InUnit and Selenium in order to completely automate the application end to end. But that's the pre-code design process. And that normally translates into some columns on your Kanban board. Everybody uses Kanban boards these days. And so this is how it would translate before development. All right. So that enables for development for everything to be holistic. This is why there are parts of implementing a feature where configuration of an environment needs to change, or some configurable variables need to come into play, and specifically new database tables need to be added. All of that is really pulled out in user experience design and then specified in the technical design column, okay? Then the test design needs to be specified because that's going to be deployed by Octopus Deploy. And then in development, oh, let me go back, I didn't mean to do that. Then in development, the code is written for not only the screens, but also the changes to the database schema, which is deployed by Octopus Deploy. And also any new variables need to be put in the right spot. And those variables need to be set up so that they can be deployed. And then the automated full system tests need to be coded properly so that that changes and that is packaged up and then deployed by Octopus Deploy. So you see that some of the way that you structure the work really enables Octopus Deploy to shine. So I wanted to touch on those. All right, next is the version control system structure. Now, Octopus Deploy needs deployable packages. Deployable packages come from deployable components of software. Deployable components of software come from building certain Git repositories. There is a way that all of the tools on the market, actually not just Octopus Deploy, but all of the tools on the market, including build servers like TeamCity and Azure Pipelines, they expect certain things to be a certain way in the Git repository. And if they are that certain way, they just fall into place because they were designed that way. If you don't structure your version control in a particular way, then you personally have to compensate and do an additional translation somewhere down your DevOps pipeline in order for those products to work as they were designed. Now, let's just go from the back to the front. Octopus Deploy likes having a NuGet package in order to deploy a particular process, a particular runtime component, a Windows service, an exe that you're going to run with a scheduler, a web application, a API web application, a SQL Server database. It likes having a particular thing that's going to run as a process, as a Windows process, or as an Azure PaaS service. It likes having that in a NuGet package. So if your application has a web application backend job and a SQL database, you're going to have 3 NuGet packages. That's the drop it in, it just works type of configuration. So all 3 of those could very well be in the same Visual Studio solution, and that Visual Studio solution is all built together in a continuous integration build and is stored in a single Git repository. Now, the systems that you work on are huge, they're complex, and they don't just have, it's not just that, it has 7 web applications and 15 Windows services and all kinds of this and 3 databases, and there's a lot going on. So look at this environment on the screen. In order for your DevOps experience to just fall into place and for Octopus Deploy to work as it was designed, you need to decompose that larger software system into multiple applications. An application is something that is built and deployed together. It has all the components have a synchronized schedule. Whereas a big software system that has 10 different applications, each of those applications could have a different deployment schedule, a different development schedule, could be deployed by 10 separate development teams and be a part of one software system that has some orchestration together, and that's fine. The software system then would have 10 Git repositories, 1 Git repository for each application. And each application that's versioned together has a Git repository. So the versioning is tied to the Git repository, okay? Follow these rules, follow this model, and everything downstream in your DevOps pipeline is gonna fall more into place. If you violate this model, if you try to put multiple Visual Studio solutions in the same Git repository, if you try to build multiple Visual Studio solutions in one Git repository with the same continuous integration build, you're just gonna be fighting everything. If you have multiple Visual Studio solutions in a Git repository and then you're trying to build only one at a time, you're constantly going to be fighting the infrastructure, and you're going to have to write a whole lot of additional script and a whole lot of additional logic to overcome the model mismatch in order to have your build and deployment tooling do the right thing. So this is the model for just to fall into the pit of success in your DevOps, in your Octopus implementation. Okay, now I'll quickly touch on the build. All right, so we've already established that a particular, by the way, you're going to have one DevOps pipeline per Git repository. So if your system has 10 applications, you have 10 Git repositories. Each of those Git repositories has one DevOps pipeline, okay? And that DevOps pipeline does building, testing, packaging, deploying along a sequence of environments all the way to production, and also has visibility into production telemetry. Okay, so what are the critical steps in a build? Well, a build is just a big test. So we'll use the test-driven development vernacular of arrange, act, assert. In our build, we need to have everything for that deployable application ready to go, or call out a specific dependency. Now, there are some cases in software systems where a database is called out as a standalone application. Legacy database is very common, where you have 10 applications. They all have the connection string to a particular database. No one application owns that database. So we have to architecturally recognize that database is an application in and of itself. It needs to be built as an application, versioned as an application, and then deployed. So one of our pipelines in that case will be nothing but a SQL Server database. Now, pretty complex SQL Server database, pretty big, but we have a DevOps pipeline just for the database. And the only thing in that Git repository is the database. And then the schema of that database gets published to the other applications. NuGet package is a great way there, just like other libraries, where now that application has access to the database schema for its own testing by pulling it in via NuGet package. And then in the continuous integration build, that application that needs the database can create the database and can execute integration tests that would require the database to be online. Then we can do static code analysis. We can package up the components. And so if a particular application needs to deploy a web application and a backend Windows service, those would be two release candidate packages, two NuGet packages that this build would produce at the end. All right, so that's important there. Now, to deploy, to even get to deployment, we need to think about our deployed topology. And we have lots of options there. We can do on-premise data center, hosted VMs, Azure VM, Azure Container Service, and Azure App Services. Now, if your web application requires a specific barcode font, if it prints barcodes, which that's a common thing to put barcodes on the screen, or any other custom font, right off the bat, you're eliminated from Azure App Services. You can't use Azure App Services because you can't install things on those servers. So if you need to install a custom font, well, you automatically have to back up to Azure Container Service. Now, if you are .NET Core, you're great because that runs on Linux. Azure Container Services for Windows, not really prime time yet. So if you're talking containers, you're talking Linux. And so if you're .NET Framework, now you're already back to Azure VMs if you need that custom font. So, but either way, you need to really think about your spectrum and where to deploy, because Octopus Deploy you can deploy to anything, but you need to think about that and work that into your architecture. So let's talk about packaging. Let's talk about the progression of packaging. So right here on the screen, we are showing the logical components And by the way, the acceptance tests are a logical component in the application. We're talking about one Git repository right now. And we're going to map the web application over to an Azure App Service. We're going to map the offline job over to an Azure function. We're going to map the SQL Server database over to Azure SQL. And then we're going to map the acceptance test over to just a running process on a hosted Azure Pipelines agent. It's happy as a clam to run an in-unit and a in-unit assembly in that fashion. Then we have 4 NuGet packages. See all the dotted lines? Each of these runtime components gets its own NuGet package. We don't package everything up in one NuGet package. We package it up in 4. Now we have some choices. What NuGet server do we push to? NuGet does have a built-in NuGet server. But if you are running acceptance tests, you can't push those acceptance tests to the NuGet server because it's a one-way. It's not a complete implementation of NuGet, and you can't get it back out. Octopus Deploy is the only place that can pull from that NuGet feed. So it's great for deployable packages, but you need to take your test assembly, your test NuGet package for your full system acceptance tests and push those into the NuGet server in Azure Artifacts. All right, so that's the architectural difference. And some people choose to just push all of their release candidate packages into Azure Artifacts so that they're in the same place, and that works fine because Octopus Deploy can easily be configured to use a different NuGet feed. But if you are going to use the NuGet feed built into Octopus Deploy, recognize that it's only for deployable packages and not for your testing packages, which also need to have the same version number so that you run the right one. So either way, if you're using Azure Pipelines, you're going to be using Azure Artifacts, at least for that. Okay, so now let's talk about the release configuration. This is after we built, after we packaged, and we need to have at least one environment for each of the 3 unique environment types. Now, everybody knows production. You need at least one. If you're using customer per tenant, you may have multiple production environments, 1 per customer. That's fine, but you need at least 1 production environment. Going back, there's the manual environment, manual testing or manual verification. Common name for that is UAT. But of course, there's lots of other common names: dev, stage, QA, test. There's so many names for a manual environment, but you need at least one. You need at least one, and a lot of organizations have more than one. Then there's the third environment type, which is the automated verification environment. I like to call it the TDD environment. Stands for test-driven development. So automated full system tests, they run against that environment. If you have automated security penetration tests, if you have automated Section 508 screen reader compatibility tests, it runs on that environment. You have different types of test suites that just require a fully deployed environment. They're not like unit tests or component level integration tests that can just run from an in-unit fixture right there on your build server. There's a lot of tests that need a fully deployed environment, and that's what that TDD environment type is for. And you need at least one, but you can have as many as you like, because if you have multiple test suites, you can run those in parallel and save some time. Okay. Now, in Azure Pipelines, we have Azure DevOps Services orchestrating the whole pipeline, and then we delegate to Octopus Deploy. Now, let's cover the 2 strategies that we have here. Let me just forward over. Now, there's 2 integration strategies. Let me go back a second. There's 2 integration strategies. One is fire and forget, and the other is orchestrated. Now, what we see on the screen is a fire and forget, which we'll go into in a little bit. But fire and forget has no deployment logs, and essentially we're just going to hand off to Octopus Deploy. Now, what we're seeing on the screen, sorry, that's the orchestrated, because we have all 3 represented. If we do a fire and forget, we would just have one stage in Azure Pipelines that is, hey, give it to Octopus Deploy, and then Octopus Deploy would model all the environments. We wouldn't even have production, so we wouldn't even know in Azure Pipelines if it was deployed to production. We'd have to go over to Octopus Deploy. But the advantage of orchestrated, and why I like it, is because Octopus Deploy passes every bit of its logs over to Azure Pipelines so that we can see in one place what's going on. And we can run tests in Azure Pipelines after Octopus Deploy finishes the TDD deployment. We can't do that if we're just firing and forgetting, because we don't know when Octopus Deploy is finished. So we want the quote call stack to return to Azure Pipelines after Octopus Deploy finishes. Now, there's a caveat. There's some advanced Octopus Deploy scenarios that don't have any parallel in Azure Pipelines. For example, tenants and channels don't have a good representation in pipelines, but the normal day-to-day cases work really fine. And if you're dynamically provisioning and configuring environments and creating parallel environments automatically, for instance, like multiple UAT environments dynamically, then you'll have some deployments that happen in Octopus Deploy without tracking in pipelines. But tenants are getting really, really popular, and so dynamic tenants are going to give you a problem with this strategy. But if you have 4 tenants and they're pretty constant, then you can configure them in Azure Pipelines and map on the top to give you visibility. Also, if you want one of your executives or non-development stakeholders to be able to click the button to approve deploying to production, you want to use the orchestrated strategy, because Azure Pipelines supports stakeholder accounts, whereas otherwise you would have to give people outside the development organization user accounts to Octopus Deploy, and sometimes that just doesn't match up. So if we dive into the TDD deployment, what we can see here is the Azure Pipelines configuration for actually deploying over to Octopus Deploy, creating the release. See, there's a step where we create the release and deploy at the same time. Then after Octopus Deploy is finished, we download a test package, we configure connection string, etc., and then we actually run our full system acceptance tests. Now, in the release number, we're actually passing that through, as opposed to letting Octopus Deploy just take the latest. And there's also additional arguments that are always important in order to be able to define some variables in Azure Pipelines and be able to pass those on through to Octopus Deploy. Because if you put your architecture hat on, you're always thinking there's a concept. Where does the concept live, and what system owns the concept? Or what system is the system of record for that piece of data? And in a lot of cases, some configuration variables, it really makes sense for Azure Pipelines to own that concept or own that piece of data and just merely pass it on through to Octopus Deploy, rather than having Octopus Deploy own that concept or own that piece of data. And so that's the mechanism you use in order to do that. And there's 2-step tasks that you can use in order to deploy an environment to downstream environments, UAT production. One is the deploy, and one is promote. Promote gives Octopus Deploy the choice to, hey, look at some things and automatically guess what the latest release is based on the previous environment in the lifecycle. And that works great in the fire and forget model. But if you're using the orchestrated model, then you're going to use Azure Pipelines to redeploy an environment, deploy a particular environment back to a previous version. And in those cases, you don't want to use promote, because Octopus Deploy is just going to look at its lifecycle configuration and then determine the version. So in order to be in control over what version, we always tend to use the deploy task when we're using the orchestrated strategy. Okay. All right. Now, I told you about the additional arguments that you can pass to octo.exe from Azure Pipelines. On the Octopus side, you want to go into the editor for a particular variable and look for this checkbox, prompt for value. If this checkbox is not checked, then Octopus Deploy will not look for this value as an incoming value. Checking this box, it says prompt for value. If you were using the UI directly, it would prompt you to type something in. But if you're using the automated way, what it's going to do is it's going to look at the context that was passed in to octo.exe or through the API, and it's going to specifically grab the value that was passed. So that checkbox does need to be checked. It's the other side of the pipe. Now, I talked about human approval, and I talked about how to use Octopus Deploy in an orchestrated way just within Azure pipelines. When you are using the orchestrated approach, you do not want to use a human approval or manual intervention task in Octopus Deploy. If you do that, it's going to wait. Octopus Deploy is going to be waiting for someone to hit the approve button, and on the Azure pipeline side, it'll essentially just go until it times out. It'll just be waiting and waiting and waiting, because Azure Pipelines just sits there and collects all the logs and waits until Octopus Deploy is finished. Now, another task that you really want to do, and you actually have a choice whether to do it in Octopus Deploy or whether to do it in Azure Pipelines. I like to do it in Octopus Deploy, is application insights and annotated release. That actually is a form of having your deployment process produce logs and telemetry, which if your software application produces logs and produces metrics and events, then the DevOps pipeline logic should as well. And this is an example of that, where we're annotating the release. We're logging that we're releasing version such and such to application insights. If you're using Azure, you absolutely should be using application insights as your telemetry sink to pull in all of your information into one queryable place. And then after that, we can do our thing. And in some cases, if it's a website and a database, it literally is as simple as 2 steps. And now in our practice, we've come in and we've seen Octopus Deploy implementations that are step after step after step after step after PowerShell after PowerShell after PowerShell after PowerShell. And right away, that is a clear indication that the DevOps environment is not set up properly. If everything in the DevOps environment is as I've explained in this webinar, then your Octopus Deploy project, the processes that I'm showing you here on the screen, yes, they will be this simple. They will be. So when you have an Octopus Deploy process that you're just scrolling and scrolling and scrolling, you might as well have a procedurable program written in the language of Octopus Deploy step templates. And that is a clear indication that you have some DevOps problems upstream that were not taken care of, and now you're having to compensate for those architectural flaws in the DevOps environment right here in your Octopus Deploy process. So yes, your Octopus Deploy process, it should be this simple. Now, these are 2 components. If you have an additional component that you have a Windows service, okay, there's going to be a 5th one. And if you have an offline EXE with a Windows scheduler, yes, you're going to have a 6th one, okay? Just depends on how many deployable runtime components exist in your particular application. Okay. Now, I want to touch on variable architecture, because variables can get out of control really, really quickly. A variable is a piece of data. You're the architect. You have to think, who owns it? Is the system of record the build system or the deploy system? Or is the system of record some external system where the data needs to be pulled in? You want to use the dry principle. Don't repeat yourself. If you don't create a strategy for configuration management, then you are rolling the dice on a management nightmare in short order. It's going to come. Every system has configuration management needs. You must design it. Don't leave it to the individual developers to just fall in place. Nothing in software design just falls in place without design. Design just doesn't happen. It has to be intentional. So when you look at your variables, think about what the applications need, and if there is room to refactor and create library sets, do that just as you would normalize a database schema. Okay, you wouldn't have repetitive things over and over again. Same thing with variables. This is a data schema, and so you want to normalize it. And oftentimes, just like the database name is shown here, this is an incoming variable. You see that it has the little prompt for value icon, and it's coming in from the build server. Just for example, we did that. If you did database name coming in from the build server, chances are all of the rest of them would come in from the build server as well. And you probably wouldn't even have all 4 of these values. You would just have the connection string. You would just have what needs to be poked into an app config or a web config, okay? But design the schema of your variables. Don't just say, oh, well, this config file is named, or this config variable is named this, so I need to put it in here, because you're going to have a complete duplicative mess on your hands. Okay. All right, let's talk about full system testing. And this is after we've done our first deployment. Octopus Deploy has deployed to our first line environment, which is a no humans allowed environment. It's only for automated testing, but this is the workflow. And this is a very critical piece when we're talking about defect removal and getting a hand on quality. If you don't have this loop, then you're constantly going to be playing catch up when it comes to quality. So this spans a lot of disciplines in order to get this loop. But before coding happens in your pre-coding design, your design and validation, we're going to specify the test scenarios. Then when we change the code, we're also going to implement the test scenarios. Then the developer does a private build, then does a git push, pushes the code up. Then the continuous integration build runs, static analysis happens. Then we do a deployment to our TDD environment. Then the automated acceptance tests run, which, by the way, they are these test scenarios. They run. Upon running, now we've done our first deployment. Upon running, then the developer creates a pull request, because we now know that all existing tests do continue to pass and the new ones pass as well. And now we're ready for a pull request. So all of this is happening on a feature branch. Then the formal inspection can happen. Formal inspection is just essentially putting a checklist on the pull request. Notice that in this loop, we include our first deployment before we do a pull request. If a pull request to master happens before we've even deployed it for the first time, then we're just setting up our deployed environments for catching stupid bugs. And so instead, the pull request needs to happen after it's been deployed for the first time and run some automated full system test. Okay. And these are the 3 columns on your Kanban board where all that work would happen. The test design is where the work is being done to specify the test scenarios. Then in development, the feature code and configuration changes and the all kinds of tests are being developed with the code. And then functional validation is the column where, hey, it is currently being deployed to our first line test environment, and it's not quite ready to go beyond just the internal team's functional validation. Does it actually work? It's not ready to go to a manual environment before we've actually validated that it functionally works. All right. Now, for full system testing, there's a really interesting capability that happens when Octopus Deploy deploys the environment, passes back the control to Azure pipelines, and then you run these tests. Because with just a couple lines of code, we can take a screenshot of every screen that is being run automatically. And so this is in Azure Pipelines. This is just showing some of the tests here. And we can see that each of these tests has 3 steps and this little picture on the right. Let's blow that up a little bit. We've expanded it now where this is a screenshot, okay? Now this is specifically using the Chrome browser with Selenium, and it takes a screenshot of everything inside the Chrome border. So we're not actually showing the Chrome browser border with the address bar, but we're showing everything in the HTML document element, or the body, inside the body tag. And so we have simple navigation on the top, and obviously a very simple screen, 3 text boxes, a button. And so the full system test is typing in stuff and hitting a button, and then it's going to insert that the right thing actually happened and it went to the right next page. And so These are things that a robot should absolutely be doing. We should not be testing that things functionally work, whether it be a happy path or an exception path. And so you put that in here, it runs automatically every time. When it fails, you have screenshots of what it looks like, so your diagnosis and debugging is really quick, and then you just do it every time. Now, let's talk about the rest of the deployments down the pipeline that Octopus Deploy is gonna handle. Here are the 3 unique types of environments: TDD, UAT, and production. We want to make sure that we don't do anything in production for the first time. We want everything that happens in production to have happened in at least one environment prior. And obviously, you see we're doing a lot more in the TDD environment than we are in the UAT environment and the production environment. So production is less and less and less. Okay. Next, let's talk about telemetry observation. We've now deployed downstream. We are in production, okay? We have a particular version number in production. We have an Azure App Service, a function, Azure SQL, and each of these environments has all of their logs and telemetry hooked up to application insights. And then if we're using VMs and we have other types of logs coming from VMs, W3, WP, and Windows application log, all those are flowing through to log analytics, so that in the Azure portal, we can query everything that's going on without remoting into anything, okay? Now, let's define telemetry. There are 3 types of telemetry. You need some of each. There are logs, there are metrics, there are events. Now, logs are the oldest from an industry adoption perspective, and that, log4net, they're just a flat file of timestamp and, hey, something happened, whatever it happens to say, okay? JSON logging has come up in popularity so that it can be queried. That's cool, but logs is a particular type. The other 2 types are magic. The other 2 types are huge enablers. This is an absolute breakthrough in the industry, and you need to dive into this if you're not using it already. Metrics and events. Now, your applications probably funnel data into a data warehouse of some sort, or a star schema, or a reporting database. And those data warehouses use a structure that's largely come from the writings of Kimball, the Kimball data warehousing method, the good old star schema, that at the center of a star schema is a fact table. And in a fact table, there's 2 types of columns. You have dimensions, and then you have facts, okay? And a dimension is what you group by. A dimension would be month, day, region, and then a fact would be transaction dollars, numbers, things that can have aggregate functions run on them. They're always numbers, so that you can say, hey, give me total sales group by region and month. And then you have the information to do bar charts or line graphs, because the data structure is not normalized. It's denormalized and has 2 types of columns, dimensions and facts. Metrics and events give you that. Events are dimensions. They are strings. They are enumerated words. Like if you were to enumerate what things a user could do in the application, that would be your set of events. It would be login successful, login failure, shopping cart add, shopping cart checkout. And they'll just enumerate what the names are for your events. And every page should certainly have an enumerated name for it, so that you could record that it happened. Now, metrics are numbers, aggregate functions, and these can be timings. These could be just that it happened. These could be counts. These could be before and after. Whatever numbers make sense in your application, and then you funnel all that to App Insights. You could even funnel it to a SQL Server database in some instances if you wanted to, but you have the source data to use all of the same business intelligence tools that other parts of your business probably use. Tableau, Power BI, even Excel's Power Pivot. And you can connect to these data sources and get information out and know exactly what your application is doing every step of the way and what the users are doing. So those are the three types of telemetry, and you need all three. Now, this is an example of some element of that you get absolutely for free just by hooking up application insights with any type of .NET application. So just hooking it up with those 4 lines of code, even without instrumenting any part of your application, you get all of this for free. And the killer feature here is that every time your application calls out to its database, you automatically get free logging of that in JSON format so that you can query it. And here's the viewer in Visual Studio. It doesn't record the data, it just records that it happened, because oftentimes you can find huge performance problems by doing some quick counts and saying, how many backend database calls does this button click translate into? We've seen systems where you click a button and 1,000 database queries have to happen before that button click can finish. And that's not going to scale at all. And if you're using the ORM, select N+1 problems happen. And if you can detect those and fix them, then quickly fix it. Now, the next screen is inside the Azure portal in Application Insights in the Performance view. And you see this highlighted part. This is the deployment marker that we talked about. We talked about Octopus Deploy, calling into Application Insights and creating a deployment marker for where it's deployed. And of course, in this environment, it's very low traffic. But if your numbers and your telemetry starts to go sideways and bad things start happening, you can come back and look and say, oh, we just deployed release number such and such right before all of our numbers started going sideways. Okay, it must have been a problem there. Now let's start debugging, as opposed to, hey, something just happened and we haven't deployed any code changes. So it's probably not in the code. It's probably a problem with the data or a problem with the environment. It can help you out. And in the Azure portal, if you click on that, then you immediately are told what deployed it and what release number. And there's even a link back to your Azure Pipelines project for that particular release. And so it gives you a wealth of information and just ties everything together. So we've gone through in a whirlwind the 7 key elements of a DevOps environment. And we've talked about what Octopus Deploy needs, what it likes, how it was designed, and how even things in your pre-code design process can affect your success creating the architecture of an Octopus Deploy-based DevOps environment. And we've got plenty of success stories and examples. It's just a joy to help so many companies be truly world-class. And we believe that when equipped with a complete and professional DevOps environment and a strategically determined process, we see teams become truly world-class. And if there's lead time issues or if there's quality issues, those get solved. We hear of teams who move fast at Google and Netflix and Microsoft, but any of your teams can be just as effective when equipped properly. And I know there's so many companies hitting you up trying to get you to outsource software development. And we don't like those companies. We want you to insource software development. We want your internal teams to be more capable because we believe they can. And so our goal is to help you equip your teams, enable your teams to be world-class. And that's what we do. We make you more effective so that you can accomplish greater things, so that you don't have to outsource. We want you to be self-sufficient. That's the big word. So there's a few example implementation that we do all the time. If you're trying to get Octopus Deploy in the mix, we can help design it for your environment. If you want us to come and do our 30-point inspection, we do that all the time. We can do that relatively quickly. Or if you have an old system that doesn't even have automated deployments at all, we can help you with a modernization DevOps plan. Or if you just like a second pair of eyes on your organization, your environment, or your process, we're happy to help there. So I believe that I have been able to work in, I'm just going to check the Q&A window. I've been able to work in all of the questions in line as we've gone, which I like to do that. And Rain has published the Octopus Deploy poster in the chat window so that you can make sure to download that. And my contact information is right here on the screen. And I love getting phone calls and talking to customers. I mean, even if you're not in a position to even get some help, I like helping people. It's fun. So there's my email address. Feel free to email me at any time. Twitter at Jeffrey Palermo. Check out the Azure DevOps podcast. It's a weekly show. And just checking to make sure that no additional questions came in. Nope. All right. And we're a few minutes early here, so I appreciate the time. I really do. I understand your time is valuable, and I appreciate you all staying for the whole webinar. If you want some more information right away, you can go to bit.ly/project jumpstart story. This URL right here on the screen. I'll leave it up for a little bit. And thank you so much for your time, and hope you have a great rest of the day.